And we are live. Currently streaming live to twitch.tv/smAsho. Doing a live daily space weather video for once and going, whoa, look at this, oh my gosh, holy crow! And looking at the sun in 304 angstroms here, there's a 48-hour video. And we got a bright area kicking up. Looks like it could turn into a sunspot today, folks, but it's not yet. It's this slightly darker region right here, so not yet showing up as a sunspot. But we got a bright region and some magnetic complexity kicking off on this day of February with too many twos. Too many twos in the date, as it's 02222020. Is that enough twos? Man, major number of twos. Here's a 171 angstroms view, and at the end of the video you'll see west of the equator, you'll see a bright spot, as well as south of the equator. So we've made a close-up of that also here on HelioViewer. And here's that image. Series of images, really. And if you're looking at the Earth and going, whoa, what is that doing right there so close to the sun? Don't worry, folks, it's just for scale. Don't freak out and lose your fecal matter. Next, we'll look at the magnetic environment here in colorized magnetogram. And you can see several areas of magnetic complexity kicking up there, the timestamps on that. And that is an ultra high res image. About 4,000 pixels. And you can see this area here likely turn into a sunspot today from the way it looks. Possibly this area down here, and some more kicking off over here too. So you see various organized regions. And we took an image of the North Polar region, as we will be studying the solar poles more and more as time goes on. And next we'll take a look at HelioViewer. And there's the 171 angstroms view, and I'll just fade this out to the magnetogram, and you can see those bright regions and the associated fields. Let's zoom in a little closer. And there you see those regions, possibly two sunspot regions kicking off here. Some interesting orientation with that southern one. This one down here, as the fields are not oriented longitudinally, but they're more north and south oriented. And that one on the equator is a cycle 24 plage at the current moment. So that's something to keep an eye on throughout the day. Perhaps it'll turn into a sunspot. And we have the chat room prepared for our viewers. So if you want to leave a comment, we may check it out by the end of the video here. We're going to look at cosmic rays real quick. KP index is at 2, so let's have a look. Let's get my face off the screen. First, Apatity Neutron Monitor and Barentsburg. There are the daily and 30-day of those two spots. Next, Athens, as we like to have a representative sample when we look at cosmic rays and not talk a bunch of nonsense. There's a 30-day state at Athens. Next, we'll look at Moscow and see if they're sending data yet. And Moscow's back to sending data. So well done, Russia. Thank you very much. And there's the Moscow neutron monitor, and you can see this has got a bigger range than the other ones. But there you go. 30 days, looking pretty flat there too. Next we'll look at Mexico City. There's 30 days of Mexico City. This is one of the ones you can archive the old data on, by the way, folks. And lastly, OLU and DOMC Antarctica. Maybe DOMB Antarctica's back to sending summertime cosmic ray data. And we see a huge spike here. At OLU, that is, I've never seen a spike that big before. That is so big that it's extended the scale massively. And it's even raised the 30-day average massively. So huge cosmic ray spike there at the OLU neutron monitor. That's the only one showing that spike. An increase of 20%. That's absolutely insane. There is DOMC Antarctica. And there's DOMB Antarctica. And that crazy cosmic ray spike at OLU just came in a few hours ago, actually. Check it out. Around 9:20 Universal Time. There it is. Big cosmic ray spike, big enough to make the entire monthly average totally different. In fact, that's weird enough that it's time to check out the Neil Gorell's Swift Bat Observatory. The Neil Gorell Swift Observatory, folks. Yes. Going to look at transients of some of our favorite objects. So we're going to look, first we're going to look at Sagittarius A star to see if we see any emissions out of Sagittarius A star. And nothing too exciting going on there that we can see. Next we're going to go to the right of the galactic center to Crab. We're talking about the Crab pulsar here. And there's the Crab pulsar. So there's the situation there. Crab pulsar being the strongest X-ray source in the sky. And next let's look at Cygnus X1, which is on the exact opposite side of the galaxy. This one located way to the left of the galactic center. X-ray source Cygnus X1, widely believed to be a black hole. We'll just call it a massive radio source. There are the transients from Cygnus X1. And lastly, let's look at Cygnus X3, which is just in the process of ramping up, and we're trying to get a hold of radio astronomers to study this thing right now. And there you see the current situation at X3, ramping back down. So this series of pulses right here may be very important, as if this gives us any insight into the precise cyclic nature of this thing. It's going to give us precise information about cosmic ray flux, as Cygnus X3 is one of the most likely extreme cosmic ray sources. And we won't get into the physics in this episode, as we got to cover the rest of the space weather. So let's talk asteroids. Let's talk asteroids. No, not Asteroids Galaxy Tour. I'm talking about asteroids. You can check them out at spaceweather.com. And today we're seeing 4 documented objects here of varying sizes, and the closest approach will be at 5.6 lunar distances. That one is traveling at 11.4 kilometers per second and is 19 meters in diameter. And you can plot those all out if you want to look at them more in depth. 10.7 centimeter radio flux still at 71, but we're expecting to see this come up as we see activity kicking up on the sun. X-ray flux is fairly flatlined here over the past 24. No X-ray flaring. Next, a real-time solar wind. Very low density solar wind here, all the way down to 1.63 protons per cubic centimeter. And solar wind speed still slightly elevated here, 473 kilometers a second. There's the data from ACE. And you see about what you would expect to see if you are a regular viewer on the magnetosphere movies. Nothing too exciting happening there, as the solar wind is fairly steady, and we don't see any major magnetic spikes or anything like that going on either. So we see a fairly uniform magnetic environment. Actually, let's look at the density also, as we see quite a low density solar wind. We don't always show the density magnetosphere movie, but this gives good insight into the way the magnetohydrodynamics works. Remember, folks, low density shown here in white, high density shown in dark blue, and that's protons per cubic centimeter. So this is one of the proxies for solar wind. This is magnetohydrodynamic pressure. And next we'll look at the ground magnetic perturbations here, as we look at the location of the Canadian North Magnetic Pole, as well as the Siberian North Magnetic Pole, as well as the South Geomagnetic Pole, which is creeping off of the Antarctican continent up toward southwestern Australia. Again, we are streaming this live on Twitch, folks, so while we don't always do that, our capabilities are constantly changing, improving, etc. Please consider helping us do so by becoming a patron, and look for more funding options available coming soon. In fact, today. We also have a PayPal if you are anti-Patreon. I know there are concerns about Patreon regarding free speech. If you enjoy the content, please press like and subscribe on YouTube also, as this video will be appearing here, there, and everywhere. And check out the performance of the BitChute videos. It is absolutely fantastic. Getting many more views on BitChute than on YouTube. So, for instance, February 19th space weather video got over 400 views, so that is extremely encouraging and absolutely delightful. And we're going to be doing a 100 subscriber special today on BitChute. So we're super stoked about that. And yeah, look for more exclusive content showing up on all of the different sites. Aurora forecast is weak, and there is the Aurora forecast. And when we get to the end of the video, we will look at the null school data on the auroras. Because this, folks, this is just a forecast. This isn't really images of the aurorae. Let's get back to some data here. GOES magnetometers are still looking spiky. No surprise there, and I've been forecasting it. And it's based on this data right here. It's the Gong 2 data taken from about 50 ground-based magnetometers on Earth, as well as one on stereo A out here on your left and stereo B out here on the right. This data 1 hour and 50 minutes old. And we're going to see continued spikiness in the GOES magnetometers here as we're seeing activity kick up. So, yeah, the magnetic environment looking spiky in terms of what the GOES magnetometers will show us. And it's all based on the way the plasma is oriented to the sun's magnetic fields. We decided to show the, this is the line of sight field plot here, to show you the way the fields are affected. And right now you can see the South Pole is extremely in charge of the current sheet. And this is the blue. The blue here is the B field, folks. That's the field going through the magnet. And then the green is the north solar polar field, and the red is the south solar polar field. And this might be a good one to look at throughout the day if you want to, folks. It's the line of sight field plot. You can use that to see the way the active regions near the equator will be affecting the B field. It is an interesting exercise in magnetohydrodynamics if you don't understand it yet. Electron flux is quite high, including relativistic electrons. And there you can see it's just approaching 1 e to the 8th. And we're expecting the GOES electron flux to reach into warning levels once again today. There's the GOES electron flux. And here's the total electron content. We don't always play this one, but we're going to show it today because we get some serious GPS errors all the way up to a reading of 50 or so there off of the west coast of South America. So that's probably going to provide a GPS error of hundreds of meters in that region. And this is part of the reason why we look at this. This also affects satellites, and we've documented many times the way we can forecast GPS errors. And I've put up many videos about it. Perhaps check our older videos if you like. Next we'll look at the ionosphere. And this is the Bureau of Meteorology of Australia. And the ionosphere is looking pretty normal actually right now. Let's bring up the latest image. There it is at 11:15. Actually pretty heavily charged up there, making it all the way up to 14 megahertz. So that's something to keep an eye on. Now, while I'm fairly critical of certain companies, certain organizations, and I cite the fact that they're a scam and not a verb, I do also give credit where credit is due when they do the right thing. And somebody is cracking down on app location access. So well done, Google. It looks like the new Android 11 is going to include additional protections. I wasn't sure if they were going to ever make another OS after Android 10 came out and they called it Android X and they stopped making statues about it, and it's bizarre. It's bizarre. How bizarre. How bizarre. But anyway, the location rules for apps and so on are going to actually get better, and for that we thank you, as there are billions of people using Android devices right now. Now, there is a groundbreaking video once again today from one of our favorite YouTube channels.
Well, once again, while doing show prep, it has been revealed to me that the end times are near. More videos by none other than Mr. MBB333. Behold the harbinger of your doom! This finger painting here is clearly a sign that the end times are upon us. Others have told us the same, and we know that our destruction is nigh.
Anyway, if you don't follow us on Instagram, check us out on Instagram. There's exclusive content there also. And by the way, welcome to the Neo-Renaissance. As we assist, study, and report the ongoing formation of unified theory of physics, we invite you to check out smAsho.org. Perhaps scroll down, click on the link to the forum, and head to smAsho.com/forum. We've got a giant repository of information about viruses, otherwise known as COVID-19. I think I'm allowed to say that, but I'm not really sure. But anyway, if you want to read all about viruses, we've been updating the page daily since January 23rd. Thanks everybody for setting up accounts at smAsho.com/forum. Here's the current state of affairs. And at least that orange line there in China is leveling out. Sadly, the yellow line at the bottom for other locations is going up. Current number of cases confirmed, 77,917. And let's do an earthquake rundown. Past 24 hours of earthquakes was quite silent, actually. We do see a deep quake here at Columbia. It's a 4.6 magnitude at 158 kilometers. Depth. Looks like the largest quake of the past 24 was a 5.2 southeast of Japan. And I'm just scrolling up the list. Please bear with me, as there's still additional content to cover. There's a deep quake in Indonesia, as they've been seeing the most deep quakes of any place in the world around that area. So north of Australia, most likely spot for a larger quake at the surface. And again, it's an earthquake lull, so please have an earthquake plan. Bunch of small quakes on the west coast of the U.S. We saw one a day or two ago at a 4.5 magnitude off the coast of Oregon. And there's one in Tajikistan at depth, a 4.7 magnitude at 116 kilometers depth. And coming in as we did show prep, a 4.1 in the deep quake capital of the world, near Fiji and Tonga at Wallis and Futuna. It's a 4.1 magnitude at 368.5 kilometers depth. If you think we know what's going on inside the planet at that depth, think again! Volcano rundown. Mount Aso producing a 6,000-foot ash plume. Sakurajima exploded. Not sure of the flight level there. Please don't attempt to pole vault Sakurajima. Mount Ibu exploding. Flight level 7,000 there. Dakono exploding. Flight level 7,000 there. Popocatépetl exploding. 21,000-foot plume there. Sangay exploding. 20,000-foot plume there. Revenador. New emissions from Aventador and Sabancaya exploding, producing a 26,000-foot plume. Please do not attempt to do the Fosbury flop, which is the form for high jumping, by the way, folks, if you weren't aware. Next, we'll look at pressure zones, and we'll let this advance about 24 hours into tomorrow on this 02-22-2020 day, Saturday. And there's where things will be at noon my time tomorrow. Looks like a major low pressure system there in the Texas stovepipe. Next, we'll look at lightning. It's lightningmaps.org. And this thing is more bound up than somebody eating only cheese. All right, there we go. And it looks like a pretty calm moment right now in terms of lightning, folks. Or perhaps it's a measuring error. I thought I saw a bunch of lightning strike in Australia. It looks like those have all simmered down. So if you want a real-time lightning map, if you hear thunder, check out lightningmaps.org. You may be amazed. Scare your friends and convince your foes that you're controlling the weather at lightningmaps.org. Next, we'll check out the U.S. Doppler radar. Some rain strike in southern Arizona there, as well as central California. And here on Null School, we're going to look at the jet streams. One little thing quick first is this actually shows the auroras. So there's the view from space. There are the aurorae. So if you want to see the real image of this, check it out. Notice the way they're spiral shaped. It's because there's a Birkeland current entering and exiting both ends of the planet. And let's get back to air here, as Null School has lots of stuff. And we're just looking at the flight level 25,000, aka the jet stream. So there's the eastern jets. Extreme meridional jet stream flow here once again, north of the Middle East. Doubled up jet streams, tripled up jet streams in the south. Here is the western hemisphere. Turn that a little bit more. There you go. Now you can see Europe and Alaska and South America. And we see extreme meridional jet stream flow all around. And it's not really news anymore. It's just normal. And next we'll look at the water vapor map over Africa and Europe, as we got a request and we try to honor requests. Please leave a comment if you've got a request. We might even consider forecasting your individual weather. I would note this looks like an extreme low pressure zone there. And that's off of the northwestern coast of Africa. And next we'll look at this part of the planet. Excuse me. And there's the water vapor situation. And actually, I'm going to look at the U.S. here. I don't always do this. I usually don't show the whole globe view. Please bear with me one moment while I animate this. And since we're doing it live, the format's a little different. So there is the U.S. water vapor map. And we're going to zoom in on Missouri, as there's a major convergence happening there. And now you can see the way the videos are made, folks. And there's that convergence zone. And you can see that moist air crashing into the more dense, more massive cold air. And it's going to slow it down as a result. And let's just move on to more stuff, as we ain't done yet. Although we are almost complete here. How about a one, a bonus, a feature? It's the local yellow dwarf in 335 angstroms. Don't freak out. Don't be like, oh my gosh, There's a star sitting over there. Holy crow. Anyway, we're out. Thanks for tuning in. Look for more content coming today, as there certainly shall be more, including the BitChute 100 subscriber extravaganza spectacularly silly special. It won't be silly. It'll be freaking serious, man. Serious. Anyway, we're out. Thanks for tuning in. Remember, stare at the sun. Don't drink it. If you do, don't drive. And since it'll never be now again, may that solar wind be at your back.